Hello, everyone, and welcome to today's webinar, An Introduction to Cloud Native Product Development. My name is Alex Janicki. I'm the Director of Marketing here for TriStar, and I'll be moderating today's session. I am pleased to introduce, we have two speakers, Shawn Shreckengost, Business Development Manager here at TriStar, and we're joined by Michael Lefleche, Manager of Channel Services for Onshape. Before I hand the mic over to Michael, I just wanted to do some quick housekeeping, let everyone know that there is a complimentary ebook. It's titled An Introductory Guide to Cloud Native Development. You'll find that in the handout section. It's a nice little comprehensive ebook that sort of will go into a little bit more than what's going to be shown today. And then everyone who registered, we are going to provide an on-demand recording shortly after the webinar. And if you have any questions, just feel free to leave them in the chat box and we'll try to get to them as many as we can after the presentation. If there's any questions afterwards or later on, feel free to visit tristar.com and visit our Onshape page. We, that you have a trial, you can sign up, more information. And you can also contact us, if you have any questions later. So with that, nice and easy, quick intro, I'm going to pass it over to Michael, and he's going to jump into this.
Awesome. Thanks, Alex. And it's nice to work with you as well, Shawn. We were just having a chat a little bit earlier about, we've been, doing CAD and data management for many, many years, back from the days of the old CADs, 4X and 5, 20, 30 years ago. So I guess we've seen some stuff over the years, and we'll try to draw some parallels in this presentation as we kind of kick off what the heck Onshape is all about, why we would do such a crazy thing as come up with a new CAD system, and give you a demo. So Shawn's going to go in and give you a demonstration of an awesome design here natively built in Onshape, and I'm going to go in and show you some of the data management and collaboration capabilities as well. So definitely ask questions. I think the questions panel is here, and we can get to them in the order in which you ask them. So let's just get right into it. Back to our little history lesson. I think I have a little gray hair in my beard, so I'm able to tell you a little bit of stories here about the story of digital transformation. Okay, so it's kind of like one of these buzzwords that people talk about, but really it's just a fancy way of saying we went to computers and we're storing stuff in a database or files or whatever it might be. And back when the first CAD systems, CAD systems were actually some of the first really high-tech things that people put onto computers for CAD and CAM. You had your big mainframes back in the 1960s where you'd store data. And then we eventually went into more of a client server environment, mini computer kind of in between there. But, let's just look at not just CAD, but, just general software, right? Big business type software from SAP, Oracle, perhaps at IBM, things like that. You had your client server type environments, right? You had stuff installed on a big server rack somewhere, big VAX system or whatever it might be, AS400. And then, you installed a small piece of software on your client, and that would perform some kind of connectivity between the two. But nowadays, programs aren't doing that, right? Since I would say 2010 and beyond, the most common way of deploying software for businesses anyway has been the cloud, right? Using software as a service, distributed architecture where the end user doesn't need to install anything special. All they have to do is have a provisioned account into these systems, and it's a lot less to manage. But the CAD systems actually didn't go down that road for whatever reason. Well, there is a big reason. It's just kind of hard to do because of all the moving parts of a CAD system and a data management system. But there's obvious benefit, and there's even more benefit in the world of CAD and PDM for SaaS than maybe some of these other systems. Like, people would find it incredibly disturbing if people were running Salesforce.com, keeping their customer access on their local computer and having it synchronized to some kind of server somewhere. that would make the process of handling customer relationships much slower and perhaps come into conflict if the synchronization didn't go right. So that's why SaaS was appropriate, and that's why Salesforce.com was probably one of the first big companies that got into that in the late 90s, early 2000s. They were really a pioneer. But all of your big companies are into software as a service. So like I mentioned before, the product development process is lagging behind a little bit on that. And let's just take a look at a little bit of the reasons why. Some of the old school systems out there, like this is the drafting room of the early 1970s, right? You can see all these engineers doing their work on their local kind of drafting boards, with their Alvin tape dots holding their prints to their drafting board, and they're drawing everything up. But they get those prints from the back of the room, or the front of the room, I guess, in this case. And there's an administrator up there that's controlling who has taken that drawing out of the system. There's probably even a little library card almost that administrator said, okay, Ed, the engineer, took this drawing out. I'm going to make a blueprint and put it in the file cabinet there as well. So all of these things were the way we did designs, and we sent men to the moon, we built aircraft carriers using this technique. Obviously digital transformation has given us a better, faster way of doing this in a more collaborative way. But the file cabinet was really the data management system, and if you were really fancy, you would do one of those library cards to kind of have a design history record of everything that's going on. But of course, computing, revolutionized, the world of 3D design, 2D and 3D design, with AutoCAD, making it widely available to create your blueprints on a computer, right? And it was really just a digital drafting board. You're drawing things, offsetting lines, just like you would with a drafting machine. And, it was, kind of hard to change these things. And then PTC, invented changeable solids, right? Back in 1988 with the powerful kind of CAD workstations that were built, like your Intergraph and Silicon Graphics workstations and things like that. To really take advantage of this computing, you could build 3D models that were changeable with parametric dimensions. Awesome technology, very expensive technology. And, at first it was a little bit hard to use. Of course, as the years went by, things got a lot easier for the wide range of people to use it. Systems like SolidWorks, kind of made that happen, as far as the ease of use, running it on lower end computers on Windows instead of Unix. And it kind of created the trend of making the software easy to use, so almost anybody could get in front of it and start using it. And of course, all the other technologies, including PTC, followed to make their software easier to use. So what do all those systems, both the drafting room and the computers, have in common? Well, they create copies of data, either through physical blueprints or through files, right? Of course, we're not storing things on floppy disks nowadays, just to kind of make a point here. Everything is stored on files, right? And even if you're using a PDM system, like, to manage the files at a company level, it's still managing the files. And only one person at a time can work on a file with all the rules of file-based, data management that are out there. So really what we did, to solve this as an industry until, the last few years, of course, which is what we're going to talk about today, is just duplicate the drafting room into a digital transformation. We transformed from a paper kind of process and took that same exact process and put it into the computing world, where the file cabinet became the file server. The database, was where the library card design record was stored, and then you had all these files floating from computer to computer, or from desk to desk in this case. And it really causes a lot of questions to arise. Is this the right version of something? Can I work collaboratively with somebody else? And the answer is typically, no. But so really, if we kind of take a look at this really quickly before we jump into the demo, this is what's happening today. You have a person who has a copy of a CAD system installed on their own local computer, and they create local copies of CAD files. Then you have another engineer with their own copy of a CAD system. They got to make sure it's on the same version if they want to communicate and everything. And they're taking those files and they're sending them around, right? Either by email, flash drive, file server, back and forth, right? And it's not one of these, it's all of these things. People will send it to whatever the most convenient method is, whether it's file server, email, whatever it is. And that creates copies. And those copies can lead to lots of questions. Even if you use PDM systems, Team Center is just one example, but any PDM system, SolidWorks PDM, all that stuff, that's a big file copying machine. And it's taking these copies, moving them around. People update their own data and it's sending it back and forth. What happens if you actually need to share with your suppliers outside of your company environment, or your customers, or even other departments in your company that don't have access to the same servers or PDM systems? These are all copies upon copies upon copies. And that's what we're really trying to solve with Onshape, okay? It's an awesome CAD system. You're gonna see Shawn build some things in a web browser that are very easy to do, and it does it very well. But the real issue is all of this, right? So that's why we decided to make a new CAD system, essentially. It's really the only way to solve the problem of files was to blow up the whole architecture, put it on SaaS, put it on cloud, and have everybody on the same version of the system, secure, of course, and remove files from the equation whatsoever. Database takes care of everything. Okay, so with that, hopefully that was interesting. Shawn, why don't you take control here, and you can show them how you would get around a system like Onshape. I'll stop sharing my screen so you can take over.
Okay, thank you, Michael. I need to be able to share my screen, Alex. Oh, Alex, are you there?
I'm gonna see if I can do it as well. Let's see if we all have organizer, right? So it should. I'll just make you the presenter. It looks like I can.
There we go. Thank you. Okay, everybody can see my screen, I hope.
Yeah, it looks good.
Thank you, Michael. Thank you, Michael. It's funny, Michael and I were speaking earlier about, our experience with product development and how we both kind of have our origins on the drafting board. And, back then I started in product development over 40 years ago, working out in China Lake, California for naval aviation and airborne weapons systems. And back then we had a drafting board very similar, or drafting room very similar to what Michael presented in the slide there, where we had a large room full of drafting boards with drawings and drawers in the back. And back then, if we needed to look up a mill spec for something, we went to the microfiche machine and printed out those documents so that we'd have them at our desk. And those were just copies. And of course, if our microfiche machine wasn't up to date, we got maybe an out of date version, looking at an older revision of some of those specs. And sometimes that caused us some issues. We actually had a drafting board that was over 20 feet long because we were working on naval weapons systems, and some of those airborne systems, they get pretty long, if you can imagine a missile hanging from the wing of an aircraft. So we had to have full-scale drawings on a J-size vellum sheet to work on those. Well, we've come a long ways since then, and I've been spinning CAD for almost 40 years now, various different products, working with PTC and computer vision, and now business development manager for TriStar. What I have on my screen here is basically my Onshape interface. When I log into Onshape, this is what I see, and we have the various areas that we can look at here in Onshape. We have a couple folders in my Onshape home. I have the ability to create documents or folders here. I have my profile. If we look at my account, we can see that my name and some of my biography here. We can go back to our Onshape. We have folders with different products and so on. I had been working on this demonstration, and I created a simple assembly to share with everybody today. And I'll go ahead and open up that assembly. This is an assembly of a bolt cutter that I was putting together. And in Onshape, it works as I want to say a multi-part or multi-body environment when you're doing CAD modeling. So what we're seeing here are several parts in what we call a part studio in a Onshape document. So in that Onshape document, we have a part studio, multiple part studios if we choose. We have assemblies. We could have multiple assemblies in that Onshape document. We can even create drawings within this document. So everything that we need for product development is found within this Onshape document for a particular product. Now, that doesn't mean to say that I can't assemble parts from other documents, but for the most part, everything that I need for this product is contained within this document. So if we look at this part studio with all the parts that I would need for this bolt cutter, there's a few things missing here. And we're going to go ahead and create the missing components for this. But what I want to show you first is that this is in the cloud, and there is no local hardware that I need other than a web browser to access this data. I also want to point out there's no file button here in this menu. Everything is saved automatically. Okay, I can actually go back and access the different versions and history of this model, and here we can see some of the different versions for this. Now, this first version that I created, version 0, was when we created the main casting model. Draft parts were created, and version 1 I created as a version of the assembly without handles, and then a note that the handle length and materials are currently under review. So after that review, we might come back and go back to working on this main version now and continue working. So we want to go ahead and finish building the parts and finish creating the assembly for this bolt cutter here. So if I look over here in my feature tree, I have different features that have been grouped in folders for different parts of this part studio. I also have the actual parts themselves, and we can turn these parts on or off if we want to do that. We can see what we're working on. We can show different features, turning them on or off as well. We can roll the model to any location in the part. So maybe I want to go back in history to this location, show some different sketches that I've created. Now, with the handle design ready to move forward, since we create parts and features from sketches, the first thing I want to do is create the sketch for the handle. And the handle is going to come off the end of this lever sketch that you see right here. So I'm going to go ahead and create a datum plane that I'm going to sketch this handle sketch on. So the datum plane that I'm going to create is simply going to be a point normal datum plane. That means it's going to pass through a point and normal to some other piece of geometry. So the point I'll use is that end point, and then I'll use this line as the point normal. We can zoom out and see that datum plane. I'm going to go ahead and flip the normal so that I can read that plane as it's facing forward, and we'll go ahead and accept that. Now on that plane, I'm going to go ahead and create the sketch for the geometry that I need to create the handle, and then I'll just look down normal to that plane. I'm going to create some preliminary geometry. I'm not going to worry too much about the geometry size. I want to get my geometry in place first, and then I'm going to make sure that my constraints are in place, and then I'll make sure that my dimension scheme is correct. So I'm just going to throw some geometry in here that's going to represent my handle, and then I'll constrain it and size it and then put it where I want it in just a moment. So the first thing I'm going to do is I'm going to create a line that represents the width of the handle. Okay, and then that line I want it to be a construction line. So I'll just make that be a construction line. And then I'm going to use this tool to create a racetrack or slot around that. So I'll go ahead and create a slot on that and then accept that slot. Okay, and I want to make sure that that gets created as construction. Okay. Now, with this, I'm going to go ahead and dial in the size of my slot. I don't really want this dimension here, so I'll go ahead and delete that. And as you'll notice, my sketch is blue in color, and that's an indication to me that that sketch is not fully constrained. So as I put dimensions on this sketch, it'll start turning black, and once everything is black, we'll know that this sketch is fully constrained. And I'm going to also create a circle in here that's going to represent the diameter of my handle, and it's just going to be a construction entity for now. And I'm going to snap it to the midpoint of that center line of the slot, and then we'll create the dimension for that. And its dimension is 0.625 in diameter. So that's going to represent the geometry for my handle. And now I just want to put it onto this lever where it's going to be. So I'm going to just constrain the sketched entities in this sketch to existing sketched entities from another sketch. So here we have some constraint options here. I'm just going to go ahead and say that I want this geometry to be coincident with geometry from another sketch. Okay, now you can see part of this is starting to turn black so that we know some of it's constrained. Okay, but one way to check the constraints is to start dragging things around to see what'll move. Now I can't move this up or down, but I can move it left and right. So we still need to add an additional constraint here. And to do that, I'm just going to create a dimension. Dimension is a constraint just as well as a geometric constraint. And I'm going to add a dimension from that point to that point and put that dimension right there and specify the value for that. All right. Now you'll see my entire sketch is turned black. So that's an indication to me that the sketch is fully constrained. So I'll go ahead and accept that. And I'm going to go ahead now and create another datum plane that represents the length for this handle. So on this datum plane, I'll just create a new datum plane. And we're just going to drag this out here. And I want that length to be 18 inches. So we'll go ahead and specify that here and accept that. Now on this plane, I'm going to go ahead and create the sketch for the end of the handle. And for that, it's just going to be a simple project the entity from that sketch that I just created. So I'll project this circle onto that sketching plane. And if I zoom back out, you'll see where that circle has now been projected. And we'll go ahead and accept that. Now I have all the geometry to create the handle tube, and then I'll go ahead and create the grip after that. So for this, I'm going to go ahead and create an extrusion using that first sketch that I just created, this sketch one. Now, when I create that extrusion, I can specify a length or up to surface or various different methods to create that extrusion. I can also create that extrusion by selecting the geometry from the sketch. If I have multiple pieces of geometry, I can select it independently. Say for example, I wanted to extrude just that piece of that sketch, or maybe a little bit more. Now, I don't have to hold the control key or anything like that. I'm just picking to highlight or picking again to deselect. So in this case, I'm going to go ahead and extrude that part of that sketch. So we'll go ahead and hit the extrude here, and I can extrude that to some length, right? Now what I'm going to do is I want to specify that that is 0.25, and I also want to give it a second direction. Okay. Now, by default, this wants to create, in this case, a new part. I'm going to add this to an existing part, and I want to turn on the part that I'm going to add it to, which is going to be, whoops.
You might need to roll forward.
Yeah, let me roll forward. So I'm going to go ahead and roll to the end here, and then where do I want to put this is on this link. Or excuse me, this lever right about there. So we'll roll to that location. And thank you, Michael. We'll go ahead and extrude that now again, and we'll give it a depth of 2.5. And in my other direction, I want it to hit that surface there, so we'll say just up to next. And you'll see that it wants to add that now to an existing part. So we'll go ahead and accept that. And that's what we have for that lever feature. Now, because this is history-based, anything that I do here will then propagate downstream to anything that uses that feature. And I actually mirrored this lever to use the other side. So when I resume the model, that will be mirrored to the other side. Okay, so let's go ahead and do that now. I'm going to just roll to the end here, and we'll see what happens with that. And we'll see that now that extrusion is mirrored to the other side. I'm going to go ahead and edit the definition for this round feature. And with that, I'm going to add some geometry to the end here. I just want to go ahead and include that round on that end of that handle. And you can see that round now propagates to the mirror image of that. Okay. Now what I'm going to do is I'm going to use that very same sketch again, and I'm going to extrude that to create my handle. So we'll just select that sketch. I'm going to extrude it. And in this case, I'm going to say up to surface and or face, and I'm going to pick the end of this handle. And I also want to create a new part out of this. I don't want to add it to an existing part. Okay, so this will now be created as a new part 5 in my part tree. I'll go ahead and extrude this sketch as well, and I'll extrude it in the other direction. And this one I'm going to extrude about 13 inches. And since it doesn't touch any other part, it'll automatically be created as a new part. Okay. Now with this, I'm going to go ahead and isolate just those 2 features, and I'm going to join them together with a loft because I want to transition from this oval shape to this circular tube. So with that, we'll just create a loft. I'll select this face to join with this face. Okay. And I have the ability to change the end condition. In this case, I'm going to use normal to the sketch profile. And we're going to add this loft to the other 2 extrudes that I created. So when I say merge scope here, I'm going to select now part 5 and part 6. And when I'm complete with this, it'll add all of that to part 5. Okay, which is now going to be my handle. So I'll go ahead and rename that to be handle. Okay, now with that, I want to go ahead and make this be a tube. So it'll be a shelled feature, and we'll just shell the end of that to the outside in this case. And then I'll select the other end as well and specify the value for my thickness. Okay, and that creates the shell feature. Okay, so as you can see, very simple to create parts and geometry within this part studio. What I'll do now is very quickly create a revolve feature for the grip on this handle. So I'm going to go ahead and sketch a brand new sketch here on the top sketching plane. We'll create a sketch. And with this, I'm going to go ahead and use some existing geometry here. And we'll just project the end of this handle on here. We'll create a center line. Since I'm going to create a revolve, I'll need a center line. And I'll specify that center line's length. This is going to represent the length of the handle. Okay. And then I'm just going to create some additional geometry for this handle, and this will be just a line very quickly here. And I'm going to trim away some of the geometry I don't want. And then I'll create a quick offset of these two lines to represent the thickness of this handle. So we'll just offset those in that direction and specify the value. Maybe a little bit too far. Yep, we'll undo that.
Yep, unlimited history.
A little typo there. All right, trim away the excess geometry. I don't want that piece there. And then we'll just create some additional geometry to finish this off. We'll do that. Something like that. These two lines will make equal. And then we'll specify some more dimensions here to make sure everything's fully constrained. And trim away any excess geometry. And here we can see that I still have a blue piece of geometry here. So I have a feeling that that's not quite constrained. Now, one of the things I can do again is I can start dragging that around to see what's happening there. And as you can see, that just needs to have some constraint that makes it parallel with the center line. So we'll go ahead and just add a parallel constraint to that. And that turns that sketch complete. All right, we'll accept that. And I'm just going to go ahead and revolve that entire sketch around this axis. And we're going to create a new part for that one and say, okay. So just that easy. Now I could come in here and finish by adding a couple rounds in here, but I don't necessarily do that right now. I can come back later. I do want to, however, change the appearance of these parts. So I'm going to just edit the appearance for the handle, and we'll make it be red. And then I'll edit the appearance for the grip, and we'll just give it some kind of gray color. And then we're going to change the name of this to grip. Okay, it's just that easy. Now, I don't need to create multiple handles because in the part studio itself, I just need to create one instance of any identical part. I don't need to create multiple parts. So for example, this blade piece we're going to use twice in the assembly, the link we'll use twice, and the handle and grip will both use twice. Each of these levers are unique to themselves, so we'll use one of those each in the assembly. If I go to the assembly now, you can see that I have, of course, part of this assembled already. I'm going to go ahead and just now insert the instances for the handle. We'll put one there, and I'm just throwing them in here for now, and then we'll also put the grip in here as well. And I'm just throwing them in here temporarily, and then we'll put them in place once we get them in here. Okay, so with this, I have different types of mate connections here. We have the ability to fasten, to revolve, to slide, different choices for assembling components. In this case, I just want to add a mate constraint to add all of these features together by fastening them. So I'm just going to select that option, and I'm going to zoom in to where I want to grab onto one of these mate connections. Now, these are explicitly or implicitly defined in the model. If there's not one that I need that is implied in the model, I can explicitly define these. But in this case, I'm just going to go ahead and grab that one right there, and I'm going to mate it to that connection right there. And that puts that handle in place and is fully defined. I'll do the same thing with this other handle here. We'll fasten that, and I'm just going to zoom in here and again try to grab that connection there, and we'll zoom over and grab this connection there. Okay, very easy to do this. I just need one connection to fasten these together, and then we'll take the handle, we'll get the inside there and put it on the end here. And then one more time. And now, as you can see, my assembly is complete. It's pretty easy. I also want to point out that when we do an insert, we're by default inserting from the Part Studio, but we may have some sub-assemblies within this document that we can choose from as well. We also can pull from other documents and standard content, such as nuts and bolts and things like that. So there's a pretty comprehensive library of fasteners available here. We have ANSI, ISO, PEM type fasteners, different categories, bolts, nuts, screws, pins, retaining rings, and so on. So we can choose from this the different types of fasteners that we want to use to add. Okay. Also, when we use these fasten options, mate options, some of them have degrees of freedom. So in this case, a revolute mate has the ability to revolve, and some of them have the ability to slide. Okay, so some act as a cylindrical mate. So this spins and slides on a cylinder. So by using those assembly constraints, we can simulate motion in the assembly. And that's what I've done here is, you know, I've assembled this in a way that I can drag this bolt cutter to simulate its motion. Okay, and if I wanted to, I can specify the limits for motion here. But for this purpose, it does exactly what I want it to do. And it's just to show how this mechanism works. Okay, and with that, I'll hand it back over to Michael, and then we'll have time to answer some questions a little bit later.
Yeah, well, I love this. This is a great workflow, and you know, not once did you have to go to File, Save As, C:\this or X:\that. No pop-ups asking you to rebuild now or save this. You know, it's just everything's very fluid. You didn't have to think about file management once, and that's really a big thing. And the way you built this is beautiful. It brought a tear to my eye, in fact. So, so very nice, like layout-based modeling and multi-part approach, and you know, very, very easy to get to advanced shapes and geometry. So I'm gonna share my screen to kind of show you what the next stage would be. Of course, you would want to go in and make and manufacture these parts. You need to release things for manufacturing and all that. And that's part of, like, you know, an engineering change management process. And that also just comes with Onshape, by the way, because, you know, we're hosting it. It can make it very easy to set up these systems. You don't need to be a database administrator. So let me, I'll make myself the presenter here. Go over here, get out of that slideshow. So here's my account here. So I have, you know, another kind of multi-part document, you know, kind of created here. Actually, I'll go to the assembly, not the drawing. So I have this like pulse oximeter thing. I have this photo cell that I need the electrical engineer to sign off on before we move forward. So, you know, back in the part studio, just like Shawn was showing earlier, I have 63 features for an advanced kind of shape here. You know, same kind of setup, all the parts listed out right here. And I have this part, if I isolate it, I've added a couple of things to it in between one ACO and the next. So everything that you're doing in Onshape, this flyout here shows us every action that was taken. Same thing would be true on Shawn's model. I could actually go through and see, oh, we made this change at this time, and this is who did it, right? So I can see Mike, the manager, at 1:50 p.m. Boston time, because that's where I am, just popped in and made that change. You can also create these branches and named versions here. So like these are important milestones, because this history becomes quite rich, because every green checkbox that you say to accept something is preserved, which is awesome, because this means you'll never lose information again in the system, because you're not saving a file on your local hard drive. It's hosted on, you know, extremely powerful cloud services. So I have this branch, and I've made some changes from, you know, when I originally released this part to another time. Like if I go to this photo cell and go to its revision history, I can actually look at that, and you can see all the revisions that have happened over time. And people spend 6-7 figures on systems to deploy PDM and PLM systems that will do this, but this just comes with Onshape. You know, all this history of what's going on, who did what and when, obsoleting things, viewing release packages. You know, this is essentially, you know, the photo cell You know, going from Rev A1 to Rev A2, and you can even do little comparisons in here to show, you know, what the differences are and stuff. So let's actually release this photo cell. Before I do that, I just want to make a quick detailed drawing of it, as you know, most people would want to have a quick drawing to document, you know, primary kind of tolerances and things like that. Of course, Onshape can create parts assemblies and drawings in the system. And, you know, I will just make it look like a real drawing, just like Pinocchio. I'm a real boy. Here we are. And I can just drop in a quick section there. So, and maybe a quick dimension, like this might be the critical dimension right here where we put in the, you know, the tolerances and all that, right? So I'll just say it's, you know, +4 minus nothing on that. So we have our drawing, and you see it's fixing the create Rev A, okay? Just slid this drawing right in here, and I can release that. So that now it will go through a workflow. And you can see I have different types of workflows in my particular Onshape company that I've designed. But you can see here I'm picking from an agile project-based workflow here, actually non-project-based workflow. There's, you know, different reasons why you'd want to do this in the Onshape system. But what it's doing is actually creating an engineering change order form. And it's showing me that I have my photo cell and the drawing of it going from Rev A2 to A3, the drawing the first time I've ever created it. Maybe, you know, I like to keep my, you know, drawing numbers the same. And then here's part number 134. And it's actually, this is actually really cool. Onshape allows you to actually publish multiple engineering change orders for the same part. It doesn't like require you to go down a sequential path. You can have a parallel process for this. And it's actually showing us this part number is included in another release. I already know that. I'm going to accept that as a known thing right now. And I'm going to say that I'm releasing this under that engineering change order number, which is going to be then approved by anybody on my engineering team. Because we're a team-based system, you can obviously, you know, submit these things for approval and have other people sign off. And that's creating this ECO right here, this triangle in the timeline. And anybody else who happens to be part of this workflow will be notified of that. Here's the action items list for somebody called Emily the engineer, and she's going to look at her timeline right here, and there's that same ECO waiting for her on her screen. So really cool that we can, you know, see that information live and in real time in the system, and she can view that release. And there it is. Now I'm going to make my windows just kind of pan down like this. So as soon as Emily says, looks good, right size, release to production, she released that. And you see, as soon as I do that, she's signed off in the rev table. You know, that's automatically up to date. And that moment in time is preserved forever and ever in this timeline. You can actually click right back into that previous moment. And that's actually showing us the actual released drawing, and it will create it in a view-only fashion, which means you can't ever make, you know, you're never going to change something that's been released. And if you did, you'd have to initiate another change notice to do that. But that's perfectly set. Rev A3, of course, it's, you know, filled out the title block with all the information, title block down there. And guess what? If I wanted to share this with somebody, you know, it's as easy as like copying a hyperlink, you know, off to this. There's share settings that you can set, just like Google Docs, right? You can share, you're not sharing a copy of a PDF or a drawing and making people install a viewer and all that really old kind of thinking. You share it, right, with the permissions that you want, view or even edit. You know, maybe I want my cable vendor to edit, right? So I could do that. You know, it's even to the point where I could even go into the comments or chat box. So I'll put it in the chat box. I don't know if everybody can see it, but you know, I just put that hyperlink in that chat box, and anybody who's on this webcast right now could actually click that link and view, you know, Rev A3 of this drawing right now. Just think about how powerful that is. You're not sending a copy that can be disconnected. You're sending the actual link to the Rev A3 of this to somebody who wants to see it. And I've allowed that by, you know, setting, you know, this anyone with link can view option. And it's okay, they don't even need an account, right? It's just a view only link so they can pick it, which means you can store this in other systems. You can Slack somebody this message. You can put it in Microsoft Teams. You can put it in your ERP system, perhaps, that you might use for your shop floor people to access drawings. You don't need to export PDFs anymore. It just simplifies and removes so many different linked pieces of technology that you need to maintain yourself now to, just letting, the database and SaaS take care of this. And this is all done in a secure way, fully encrypted. Nobody can actually intercept this because it's not really a file. It's instructions on the servers. They would have to, it would be an insane amount of effort to try to figure out how to actually intercept this. So it's a modern method to release these things and get things out. Of course, you can export things and import things into the system. But I think you'll actually, extract a lot of time savings when doing this. So that's really what I wanted to just show, because Shawn did such a great job at the foundational elements of the system. You're gonna be able to create geometry very quickly, advanced geometry very fast without anything getting in the way, and you're gonna be able to get to production and manufacturing very quickly as well because of the data management system being built in. So if you're ISO 9000 or you have other quality control requirements, this is going to be a huge boon for your productivity and safety as well. Not to mention a huge cost savings because you're not having to maintain all of your own systems anymore, which is the whole point of SaaS, right? I think there was a slide in here that kind of talked about it. So we're all working on data centers now. We're not working on user on-premise systems. Like you guys that are running install-based systems. I know I've been doing this for 30 years. I don't want to even think about, and same for you, Shawn, probably, how many man years we have spent installing CAD software. It's almost kind of scary to think about what else we could have been doing with our lives. Yeah. So like all of these things, like either you as the engineer or some IT person needs to maintain and install on your own local computer or your own premises for your own file servers. People are kind of starting to migrate to provider managed systems, right? Where you can offload some of the server stuff to the cloud, Azure and Microsoft technologies, things like that. So you can virtualize things, but people aren't really going in and virtualizing their CAD systems because it's such a big thing, graphics intensive application. It performs very poorly in those kind of environments. There are things like platform as a service, PaaS, which does everything except the local installed system, and there are some companies that are doing that. But by far the most popular and easiest for the end user is full software as a service, where there's nothing to maintain on on your side, right? Full software as a service. You don't install software, you just sign in and go, and everything's up to date. And that's what Onshape is. So Onshape is a PTC technology. I think we've been with the family now almost a year. We were founded 7 years ago by all of the same founding team members as SolidWorks, in fact. And a lot of the people that came from SolidWorks used to work at PTC before that, or computer vision. And so it's like this full circle that's been created here back to the parent company. So PTC sees this as obviously critical for customers that want to design faster, that want to start up quick, share with each other, work in a distributed way. Of course, in our environment today, it's more important than ever to be able to have quick access without dealing with installing things, VPNing things, because we don't know if we're going to be in the office today or not, right? We might have to go back home. I know I'm working from home right now. So all of these things lead to software as a service being a very critical thing for you to consider if you haven't already. So that's really where I want to kind of leave it, I should say. If there are any sort of questions from everybody on the call, we'd be happy to take them. And of course, I think something that you want, you can use the questions box here, but while people are typing in their questions, you know, the ebook that's attached to this in the handouts is an excellent piece of material. I'll just open it up here. You know, this kind of explains things in a kind of a deeper way as to what digital transformation is all about and why Onshape did it this way. Of course, I think Shawn and the team at TriStar would be more than happy to do a one-on-one demonstration with you and your company to you know, talk about Onshape if this is something that you're interested in migrating to, or if maybe perhaps you're a new company and you're just getting started. This is obviously going to be a great boon to your organization. Something else to consider is that Onshape on the enterprise plan gives you analytics, so you can understand who did what and when and at what time and where they were in the world. Like here's my my colleagues around the world that I've been working with on this particular company that I'm working with. I can probably just crank this up to today right here and see all sorts of other users coming online. I just started working with a guy in Singapore and Barcelona, a couple of my team members here. So it's really interesting to be able to get this like deep information about your design activity. Helps you make better decisions as an organization. So I think we've wowed people, Shawn. I don't see any questions here in the panel. So it's a lot to think about, but hopefully it's exciting, gets your juices flowing, and you reach out to us and we can chat a little bit more about you and your unique situation.
Yeah, excellent overview, guys. Thank you, Shawn and Michael, for that. And then as Michael said, if you do want more information, interested in a trial or a demo, just visit tristar.com or simply call your local TriStar sales representative. And with that, I just want to thank everyone and enjoy the rest of your week.
Thanks.
Thanks, everybody.